All right, so wrapper classes, we know most of them, like why do we need them and how can we use them, right? Primitives versus reference types, primitive and reference types, okay. Direct value reference to an object on the heap, methods, none, full, okay. Generics cannot be a generic type, and we will see more in our generic topic. Here you can see primitives, direct values, objects, okay. We have 8 wrapper classes. Every primitive has a matching wrapper in our java.lang because java.lang is auto-imported and we can use them without an import statement. So for byte, we have this one, for this one, okay. So most of the difference is for int and for char, okay. Other things just you can make first letter capital, okay. Then for this one, we have size 8 bits, 16. You can take a look, okay. For boolean, this one is JVM dependent, right? Now create an example. You can take a look here, and we have seen those things, right? This one is just quick revision, you can say, for wrapper classes. Naming pattern. 6 of the 8 wrappers are simply the capitalized primitive name, and for int, integer, and char for character, okay. You can create your wrapper objects. Value of is the preferred form. Integer dot value of this one, but we don't need those, and we will see why. Value of uses an internal cache for small common values, right? The integer cache, and we will see what is that. Covered in the next chapter, okay? For those values, it returns the same shared object every time rather than allocating a new one. Also, we have discussed this thing as well, okay, in our series. Constructors are deprecated, okay. Integer, this one, so definitely you don't want this one because it will create new object. Since Java 9 removed later, every wrapper's public constructor was deprecated in this one. Always use value of or autoboxing. Autoboxing is compiled to a value of call under the hood. In fact, we have seen this one, autoboxing and unboxing, okay, but still we will see in next chapter. We have some useful methods like parseInt, to string, to binary string, to hex string, octal string, arithmetic helpers, compare, max, min, sum, constants, okay. Integer.max value, we have this one. You don't have to remember this one, okay. Now for double, we have some. Don't compare doubles with this one, okay. Double dot nan equals to double dot nan is false. To check for not a number, always use double dot is nan, okay. And for general double equality, compare the difference against a small epsilon rather than using this one. Okay, now we have some character methods. We have is letter, is digit, okay, is letter or digit, is white space, uppercase, lowercase. We also have case conversion methods to lowercase, uppercase, numeric value of a digit character, right? Get numeric value. Probably you need these kind of methods in your DSA, right? Then we have some Boolean methods. First one is parse Boolean. Okay, parse Boolean from here, then parse Boolean. So parsing only true, case insensitive returns true. Anything else is false. Logical operations as static methods. Logical AND. Okay. Now, next one is parsing strings. Every numeric wrapper provides a parse and something that static method that converts a string to the corresponding primitive. Integer.parseInt, parse long, parse double, this one, okay. And now with the radix number base, int binary, integer, parseInt, and you can define here that now you will get your binary, okay, format. And if you want hex, then you can define here, okay. What do you want? If you want octal, you can define here. Now, invalid input throws number format exception and unchecked exception, right? So we don't have to handle this one, and we will see checked and unchecked exceptions in our next topic. So you must validate input or catch the exception at system boundaries such as user input or external APIs. Okay, now next one is why wrappers exist. Collections and generics require reference types. Okay, and we will see collections and generics. All right, why do we need those? Java generics work only with reference type. We cannot declare something like this one. Now, thanks to autoboxing here, something we don't need. Okay, we are doing something these kind of operations, then basically our compiler do autoboxing automatically. Okay, we rarely need to write something like integer dot value of. Explicitly the compiler inserts it for us. Now, representing no value, primitives cannot be null, right? A wrapper can, because wrapper is basically one object and object can store null, which lets you represent missing or unknown values commonly needed when reading from databases, right? For more structured handling of missing values in your code, you can consider optional integer, right? Instead of a plain nullable integer. And we will see this one as well in our later part of our series. Now, next one is utility methods. Each wrapper is also the home for the static helpers that work with its primitive. Okay. Without wrapper classes, these would need to live in some separate utility class. Then we have some questions. Why are wrapper classes needed? To bridge the gap between primitives and Java's object-oriented APIs like generics, collections, reflection, or many framework APIs require reference types. Okay. Why are wrapper constructors deprecated? Because always allocates a press object. So we can use this syntax. All right. Now, can a primitive variable be null? No. Now, what exception does integer.parsing throws on invalid input? We have seen this one, number format exception. This one is subclass of runtime exception. Okay. So let's say we are doing here something. We can remove this one for now. Just make this simple. Okay. Or what we can do is we can remove all these things. I think we don't need those. I will clean this directory and maybe you can start a new directory. That's fine. But for now, here what we can do is we can declare package this one. And now here, let's say int a equals to integer dot parseInt this one. Let's add some character here as well. When you run this one, first, let's just compile this. Okay. So now what we can do is cd module 2, and after that we can go inside src and then our this com and then API and then main. Okay, we don't have to write this one for now. Now we can compile main.java. Okay, so you can see here some intelligent stuff is going on, right? What we can do is, can we run here directly? You can see here we got one runtime exception, that is number format exception. Okay. All right. Summary. Each wrapper doubles as a utility class with static methods for parsing this one, formatting this one, and comparison. Wrappers are essential for collections, generics. Okay, and we will cover these topics later. Next one is autoboxing and unboxing. Autoboxing and unboxing. Writing integer dot value of this one or my integer dot int value every time a primitive needs to become an object, okay, or vice versa would be noise in every collection using program. So Java 5 introduced autoboxing and unboxing. The compiler inserts these conversions automatically and letting you mix primitives and wrappers freely, right? Okay, so this convenience comes with several pitfalls that every Java developer needs to know. First one is autoboxing primitive to wrapper, right? So let's say we have this primitive, we don't have to write. Our compiler actually generates this one, and this one works for every primitive. We have seen these kind of things, right? Then unboxing wrapper to primitive, this and what you write here, and the compiler actually generates num.int value. Okay, so you can do this one directly. You don't have to do unboxing as well. Unboxing happens whenever the compiler sees a wrapper in a context that needs a primitive, including assignments, arithmetic operations, and comparisons with primitives. Okay. Now, autoboxing in context with collections, generics accept only reference types. So every primitive you put in into a list, map, or set is autoboxed. So let's say you are adding this one, then basically our compiler is converting them to their wrapper objects, okay, under the hood, like that. Okay. And we don't have to write these kind of syntaxes. Unboxing on retrieval. Now, when you get this one, numbers dot get this, then basically under the hood, we are doing this one, okay, dot int value with method parameters and return types. Same thing, okay, in mixed expression. So basically, don't get confused here. You can work with them directly, primitives and wrappers, okay. Unboxing and autoboxing happens under the hood automatically. Now, this one is important, the integer cache. So, Java caches certain wrapper instances to avoid redundant allocation. For integer, the cache recovers every value in the range from this to this by default. Okay. So when you autobox a value in that range or call integer dot value o with it, Java returns the same shared object every time. Let's say you have this one, and if you call double equals operator, that means we are basically comparing the um, reference, right? Memory address. And if we are getting here same memory address, that means our Java cached these values and we will be getting true here. For that, we will not get true. Okay, this one is false because we have this range only. This is one of the most notorious sources of bugs in Java. Okay, this operator on wrapper references compares identity, not value. Okay, inside the cache range, it appears to work. Okay, outside it does not. Critical rule: never use this one. Okay, we can always use this one for objects dot equals for null safety. Okay, this one compares object references, not the values they contain. And we know this rule, okay, for a long time now. Similar catches exist for byte all values, okay, because this one is very short, and for short, for long, character. Okay, so this one is important. And Boolean true and false. The exact range for integer can be adjusted via the this one, okay. JVM option, but production code should never depend on catch behavior, right? Now, next one is the null unboxing trap. We know that wrappers can be null, right? And unboxing our wrapper to any primitive, if let's say we have null value, right? And we are doing unboxing like under the hood, then we will get null pointer exception, okay? This is the second most common wrapper bug after this one. All right. Now what we can do is explicit null check num not equals to null, and then we can do default value via ternary, okay, optional Java 8 plus optional dot of nullable, and we will see these methods in our later part of our series. So you can skip this one for now. We will see one optional class, okay, and we will do one deep discussion on this one. Then this one as well, okay, external data sources. You should always pay attention to your external sources. Okay. Performance hidden allocation in loops. Each autoboxing inside a hot loop allocates a wrapper object, at least for values outside the cache. Okay. In tight arithmetic loads, this can multiply memory pressure significantly, right? So we have one rule: use primitives in numeric heavy loops. Box only when a reference type is genuinely required. All right. Ternary operator trap, okay, requires both branches to have a common type. When one branch is a primitive and another is wrapper, the compiler unboxes the wrapper to unify the types. And if that wrapper is null, we will get this one, null pointer exception, NBE. Okay, so let's say we have this and this. Now result false, A and then X. We will get this one even though A is not the chosen branch. Okay, we will still get this one because this condition is now false. So practically we should have got this one without any errors, but still we will get this because our compiler tries to do unboxing for this one for A, because try to match types, okay, on both sides, even though we know that we will not get this value. Okay, still we will get NBE. Both sides of the ternary are type checked for unification before the condition is evaluated. Okay, we have safe alternatives. Okay, now explicit null check, integer result, this one. First we can check, okay, null check, and then we can write our condition. Okay, some best practices. We will not focus on this one because we have covered a lot, almost everything we have covered in our previous series. Now let's move forward with our new chapter, which is enums.